Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Paper 2 Foundation Tier from 2025. Question number 4 is on the topic of forces. Car X and car Y have engines that produce the same maximum forward force. The cars are the same shape, but car X has a greater mass than car Y. How does the maximum acceleration of car X and car Y compare? Now, car X, same shape, car X has a bigger mass. If it has a bigger mass, then it will have a smaller acceleration. Remember the equation F equals ma. Mass is inversely proportional to the acceleration. So as the mass increases, acceleration decreases. Car Y has a mass of 900 kilogram. Car Y accelerates at 2.5 meters per second squared. Calculate the resultant force. So mass is 900 multiplied by 2.5. That gives me 2250 newtons. 2250. A car moves at a constant speed on a level road. Figure 4 shows the horizontal forces on the car. The driver makes the car accelerate until the car reaches its maximum speed. Explain how the horizontal forces on the car changes as the car accelerates to its maximum speed. Now, if it's accelerating, the driving force should be increasing. Initially, air resistance is 0 when it was standing still. Now, as the car speeds up, as the driving force increases, the car accelerates. As it accelerates, there is going to be more air resistance. So air resistance slowly starts creeping up from 0 all the way up to the same force as the driving force. At this point, when the air resistance and the driving force are equal, it would reach terminal velocity of maximum speed. It can't go any faster than that. So the driving force increases. Increases and has a maximum value. At the start, driving force is greater than air resistance. So there is a resultant force. However, air resistance increases as speed increases. So the resultant force decreases when the air resistance is equal to the driving force driving force at maximum speed the resultant force is 0. So it's not accelerating at that point. They're talking about the horizontal forces, so we need to talk about air resistance, the driving force, and the resultant force, all three of them. We don't have to actually mention acceleration here because we're not talking about the acceleration. To pass a driving test, drivers need to understand the difference between thinking distance and braking distance. Choose the sentence, complete the sentence, choose the answers. The thinking distance is affected by the driver's reaction time. Complete the sentence, choose the answer from the box. The braking distance is the distance traveled by the car under the braking force. No, that would be wrong, isn't it? Yeah, that's actually correct. Sorry. Yeah, that is correct. Figure 5 shows how speed affects the thinking distance and braking distance of a car. So the thinking distance is the bottom line, the solid line. The braking distance is the dotted line. So the thinking distance is actually increasing steadily in a straight line. It's constant. Whereas the braking distance is non-linear. It is still increasing. It's actually increasing much faster than the thinking distance. The car is moving at a speed of 100 kilometers per hour. Calculate the stopping distance of the car. Now, stopping distance is equal to equals thinking distance plus braking distance So let's find the thinking distance and the braking distance at 100 kilometers per hour. So at 100 kilometers per hour, which is here, let me draw a straight line. So that point and this point, thinking distance is 20 and braking distance is 60. So we just add that up. So 20 plus 60, that gives me 80 meters. Which two of the following would increase the stopping distance of a car? Fitting new brakes would actually decrease it. Fitting new tires will decrease it. The driver being tired, yes, that increases the reaction time, which increases the thinking distance. That would increase the stopping distance. Driving uphill would actually make it shorter. Driving on a wet road, yes, that would also increase the stopping distance. That brings us to the end of question number 4, and I will see you in question number 5.